functions. So here the formula was given to us as sine hyperbolic is equal to e to the power x minus e to the power minus x upon 2. कर ली मैं मैसेज भी कर रहा हूं उसका नहीं इस पे कर चैट में okay. So Ashpreet, have you started recording the session?
Yes, ma'am. Yes.
Excuse me, ma'am.
Yes. I can't hear you. Please be louder. Hello.
Hello, ma'am.
Yes, ma'am. Recording has been started.
Okay. Now somebody else had some other doubt.
I had a small doubt in the all marks file. If you could select, I could.
Yes, yes, yes. Please tell me. What is it?
Ma'am, if you could please select the all marks and file, then I could point out the doubt.
You want to share the screen?
No, ma'am. I wanted you to select the all marks file which was there in your screen.
Okay, my on marks for. Okay, okay.
Yes, ma'am.
I'll just share. So my all marks example is this. Yes.
Yes, ma'am. For displaying the 3 marks obtained by Deepak, we first typed 4. That was 44th row, right?
4th row.
Yes, ma'am. And comma, then 1 column 3. That was for first 3 entries, right?
First 3 columns. See, MATLAB always has this rows, comma, columns structure. Whenever you write it in a bracket, in round bracket, for the matrix, the first entry is for the rows and the second entry is for columns.
Okay, ma'am. So suppose I wanted to get the first 3 entries of the 3rd column. So how would I type? That would be 1.
Get the first entry.
First 3 entries of the 4th column.
That means you want first 3 entries of the fourth column. Okay, the 4th column is this, and you want to get the first 3 entries. That means you want to get 36, 76, and this 73. So we want the rows are going from 1 to 3. Okay, so 1 colon 3 comma, and the column is the last one, which is the 4th column. Okay, so let's see if all marks. Sorry, I'll save it in say M. Okay, now let me run. Is this what you wanted?
Yes, ma'am. Yes, ma'am. Thanks for rectifying my doubt. Thank you. Ma'am, you can continue.
Okay, so this was the function that we created for sine hyperbolic and cos hyperbolic. Okay. So now to run this function, let's see. Let's talk about the script versus function first, and then we will see how to call this function. Okay. So these are the few examples where you can use script and use functions. Okay. Functions, since I told you they have their own variable space, you can easily have the privilege of using the same variable in the function also, and as well as in the command window. So that's where the advantage lies. So use scripts when you want to make small calculations, and use functions when you actually want to calculate values as functions of variables. That's what you have in your entire machine learning, artificial intelligence. You have an input space and you have the feature space. So that is nothing but a function. In that case, you have to use functions. Okay, so for the differential equation, there is very famous MyODE function. You can create and then you can use. So calculate the properties as a function of temperature, concentration. That is how the real life scenarios come into play in terms of mathematical modeling. So there are several types of functions, user-defined functions, function functions. Special types of functions are sub-functions, nested functions, and private function. So we'll see one by one. User defined we just saw, which was this function to calculate the hyperbolic sine and cosine functions. So this is what we did here. Okay, we made this function. To call this, if you write CLC, if you write on the command window the function name, you cannot run. Okay, if you try to run this, see, if you try to run this, it will give you an error. Okay, you can't do that with the functions. You can run the normal M file, but not the function file. So what you have to do to call, so you have hypersc of the output input you have to pass. So I will say 2, and I'm giving the value as 2. So it is giving me the last value or the first value. It is not the good way to call a 2 argument function. You have to specify the output arguments here in terms of some variables. The variable name can be anything, A, B, or you can use the same variable name. You will get the values. Hypersc of 2. So now you will get both the output arguments. Okay, so this is a good way of calling a function which is having more than one output variable. Okay, so this is the way to call. So here you can note that in this workspace, there is no sin h cos h stored here. In this workspace, there is only what the variables are defined here. A and B are present here, but sin h and cos h are not present here. They are actually evaluated in this hypersc function's own working space. Okay, so that's where the local scope of variable comes into picture. And if I write help hypersc, then it will give me the documentation that I have given it in form of the comment. Okay, the same thing it will return. So now you can understand all those functions of sine, cos, which MATLAB already has, how they are created. This is the way they are created, and the documentation has been written in terms of the comments. Okay, and here the function is stored in the MATLAB directly. If I change this directory, say IPC, and now I try to call this function, let's see what happens. Okay, it is running. So I think I'm getting confused between. Anyhow, so you can call this function this way, and the three things to note here are the workspace of the function is different from the MATLAB. So as seen here, the sine and cos h, which are the output arguments here, are not stored anywhere in the MATLAB workspace, and the documentation that you give while creating this function will appear when you write help hypersc. Okay, so this is the user defined function. So you can give any name to the, while calling, you can give any name, A, B, sin h, cos h, anything. So functions are the functions whose input arguments include the name of other function. Okay, like here eval of sine pi by 4 is actually taking the input as some other function. Sine is already a predefined function in MATLAB. So eval of sine, that means this function eval is taking another function as the input argument. Phi-val is again another function which is also taking input as some other function. Other example of functions are EZ plot and F plot. Okay, so this you can go to the documentation and see. So then we have the subfunction. So it is possible to place more than one function in a single file. So if more than one function is present in a file, the top function is primary function and others are subfunction. So we will see how. So subfunctions are accessible in the same file only. That is, they facilitate the primary function, and subfunctions are often used to implement utility calculations for a main function. So this is an example of subfunction. This is the primary function. This is the primary function, and these three functions are subfunctions. So when you are defining the primary functions, you are making use of these three subfunctions. Okay, add, mul, and dive. So these three functions will facilitate only this primary function. So this function is actually calculating the arithmetic operations of addition, multiplication, and division, which is again calculated by the sub functions add, mul, and div. So this is an example of sub function. So I think I would have done this here. Or if you can just take the screenshot and you can try it after the lecture. Okay. Then you have the nested functions. These are the functions that are defined entirely within the body of another function called the host function. So variables defined in the host function are visible inside any nested functions, and nested functions are not visible in the host function. So this you have to remember that the variables which are defined in the host function are visible for the nested function, but the variables in the nested functions are not visible in the host function. So this is an example of nested function. So here you can see the main function also has another function, add. It starts with this add, and then this function is defined here only. Okay, in the there is no concept of primary or sub function here. There is nested function, मतलब एक function के अंदर में दूसरा function है. Okay, so when you actually execute this, you will see how the working, these display messages. You will think that looking at this, you will think that the display message of you are in the addition sub function will should come first, but it is not the case. जब आप इसको execute करेंगे तो आप देखेंगे कि you are in the division sub function is the message that will be displayed first. Why? Because of the line by line execution of the commands. How? See here, when a is equal to add, I told you that the assigning is from right to left. So in the right of this, your value of a is got by the function add. So add function, it will directly go to the add function. Add function is here. It will execute this, and then it will go to the next line, which is this, which is taking the value from the mul sub function, mul function. So from this line, it is directly going to this function. Okay, unlike here. Why? Because assigning process is depending on this function. Okay, m की वैल्यू के लिए मल फंक्शन पे डिपेंडेंसी बन रही है और मल फंक्शन इसका यहां पर है, तो इसीलिए डायरेक्टली यहां से यहां पे एग्जीक्यूशन ऑफ द प्रोग्राम चला जाएगा और आपका जो है मल फंक्शन में जाने के बाद में d की वैल्यू आ जाएगी एंड देन कैपिटल D की वैल्यू div फंक्शन से आएगी. सो डायरेक्टली फ्रॉम हियर इट इज गोइंग टू गो टू div फंक्शन. Why? Because of the assigning process again. So once it is in div function, it will give the value for e, and then it will display this message as first, and it will go back here. It will display this message and then this message. Okay. I hope this is clear. I will show you how. Yes.
Yeah, ma'am. I was unable to join when I was joining at 4:30. Right now, I have joined. So can you please explain up right now up to what you have explained?
Beta, it's almost more than half an hour. So what I will do is you can see the recorded lecture and the slides. Yeah. Okay, and then even if उसके बाद भी कोई doubt है, you can.
Ma'am, the slides will
कहाँ
be
पे
shared.
मिलेंगी?
Slides I will share. Yes.
हम क्लासरूम पे मिलेंगे.
Google Classroom video recorded lecture.
वो आपको आपके इसमें ना मेल पे आ जाएगा. आपके पास सबके पास ड्राइव है ना?
Yeah, ma'am.
Yes, ma'am.
यहाँ पे आ जाएगा. Okay. So I am just searching for the function which, yeah. So this is the function which I made here to demonstrate the nested function. So then when I call this, I will take the output arguments as x, y, and z equal to arithmetic 2, 5. So it is giving me, see, you are in the division subfunction. So this message has been displayed first. and then this message has been displayed, and then this message has been displayed. So you have to understand the logic behind the execution of this. Okay, I hope this is clear. Okay.
Yes, ma'am, I have a doubt.
Yes.
In this, for example, the first display, why have we not written that before the mul?
Sorry.
Like the display command of your in addition subfunction, why have we not written it before the m equals mul?
That is because to demonstrate how I could have written it. If I write it here,
Yeah.
if I write it here, then obviously this will be the first thing to be displayed. But just to demonstrate the execution process, I have purposely written it this way.
Okay. Thank you.
Okay. Yes, sorry. Okay. So I will move forward. Then you have the private functions. These are primary functions again, just like the user defined, or they can be subfunctions, or they can be nested functions, but they are stored in some other folder named private. You can name, they are not visible outside that folder. Private functions are invisible outside the present directory. They can use the same name as functions in other directories. So the advantage of these kind of functions is that you can make your own version of the inbuilt functions that are already present in MATLAB. If you think that you can, improvise certain type of functions. For example, we have the plot function here, and you think that plot can do more, then what happens is you can write your own function for plot with the same name and save it in some other folder named private, and you can go to that directory and you can execute that. So this is how the toolboxes are also made in MATLAB. Okay. So this is an example, like I have a private folder here and I have made a function named calc. So this is again calculating the arithmetic. So if I want to call this, it will get called now, but outside this, it will not be called. So see here, X, Y, Z, and W equal to calc 2,5. So it is giving me the output. So now if I change the directory to MATLAB only, and I write this, it will give me an error not found in the current folder or on the MATLAB path, but it exists in this path. So we have to change this path here and then we can get it. Okay. So this is about functions. If you have any other doubt, you can write to me, or we can take it up at the end. Now I would start with the image processing, which was actually the topic for this. Okay.
Hello, ma'am.
Yes.
Ma'am, in the previous 1 or 2 slides back, you were showing that mul and those. Can you show that slide again, ma'am, please?
This one?
Yes. No, ma'am. Yes, ma'am. Ma'am, over here, a equal to add a comma b. After that, function c equal to add a comma b. Then c equal to a plus b. We can also write a equal to a plus b, no, ma'am.
You can do that. There's no problem, because they have their own variable space, so you can do that also.
And then why did you write that function c equal to add a comma b? You can also that function a equal to a comma b. You can also write.
Yeah, you can write that also. That's what is the point here, na? You can name the output argument variable as anything, because all the functions have their own variable space, working space. So it will not matter. You can write a also, then also it will display. So if you want me to do that, I will do it here and show it to you.
No, I'm okay.
Okay. So
Ma'am, will you be providing us with this PDF?
Okay, I will do that.
Okay, ma'am.
So if you call it again, I think this was it. It is giving me the same things. Okay. Okay. So now I would like to start with the digital image processing. So outline of this talk is I will talk about what is digital image processing, then what is a digital image, how does the image is seen in the computer. Then we'll talk about some metric operations that will be a part of image processing, and we will talk about some simple applications in MATLAB. Okay, so vision is the most advanced of our senses. So it is not surprising that images play the single most important role in human perception. However, unlike humans who are limited to the visual band of electromagnetic spectrum, imaging machines cover almost the entire electromagnetic spectrum, okay, ranging from the gamma to radio waves. So they can operate also on the images generated by sources that humans do not customarily associate with images. So these can include ultrasound, electron, microscope, and computer generated images. So this digital image processing, it actually covers a wide and varied field of applications. So there is no general agreement among various authors regarding where image processing stops and other related areas such as image analysis and computer vision begin. So sometimes what happens, a distinction is made by defining image processing as a discipline in which both input and output of a process are images. So as I said, there are no clear-cut boundaries in the continuum from image processing at one end to computer vision at the other. So, however, a very useful paradigm is to consider three types of the computerized process, as seen in this slide. A very good book by Digital Image Processing with MATLAB by Gonzalez. It actually demarcates, distinguishes image processing in three categories: low-level processing, which is involve primitive operations such as image pre-processing to reduce noise, contrast enhancement, and image sharpening. A low-level process is usually characterized by the fact that both its inputs and outputs typically are images. Next comes the mid-level processes on image, which involves tasks such as segmentation, partitioning an image into regions or objects, description of those objects to reduce them to a form suitable for computer processing, and classification, which is the recognition of individual objects. So in this mid-level process, it is the inputs generally are images, but its outputs are attributes extracted from those images. So example, edge detection, contours, and the identity of individual objects. And then finally, you have the high level stuff, which involves making sense out of an ensemble of recognized objects as an image analysis, and at the far end, performing the cognitive functions, so normally associated with the human vision. So these two, the last two, are interest of the higher research level purposes, and low level is basically what is already present with you in the form of your filters that you use for enhancing the photos, everyday photos that you take, and then you post it on Instagram using various Canva features, or using your own smartphone features, filters. So these are all, they all come under low level image processing. Okay, so the ancient way of capturing images through camera obscura. So it is shown in this slide. So a camera obscura is a darkened room with a small hole or lens at one side through which an image is projected onto the wall opposite the hole. So this term camera obscura can also be analogous to constructions such as a box or a tent in which you have an image of the outside which is projected inside. And it's as good as, artists are able to paint from real life more accurately. So camera obscuras with the lens in the opening have been used since the second half of the 16th century, and they became more popular as an aid for drawing and painting. So it can this camera obscura box was developed further into the photographic camera in the first half of the 19th century. So when camera obscura boxes were used to expose light sensitive materials to the projected image. So it was mainly used as a means to study eclipses without the risk of damaging the eyes by looking into the sun directly. So that was the main motivation behind this camera obscura. So as a drawing aid, this camera obscura allowed tracing the projected image to produce a highly accurate representation, especially appreciated as an easy way to achieve a proper graphical perspective. So without a lens, a camera obscura, without a lens, but with a very small hole is called as pinhole camera. Although this more often refers to a simple homemade lensless cameras in which photographic film or photographic paper was used. So this is all about the history of how the image capturing process was. And then came the digital cameras, which gave a whole new meaning to the idea of painting by numbers, the analogous to digital. So unlike the old style film cameras, they capture and then they record images of the whole world as using digital technology. So in other words, they store photographs not as pattern of darkness and light, but as long strips of numbers, which we will see as arrays and matrices. So this has many advantages. It gives us instant photographs, allows us to edit our pictures, and makes it easier for us to share photographs using your mobile phones, email, websites, etc. So digital cameras look very much like ordinary film cameras, but they work in a completely different way. So when you press the button to take a photograph with a digital camera, an aperture opens at the front of the camera and light streams in through the lens. So far, it's just the same as film camera. From this point on, everything is different from this. So instead, there is no film in a digital camera. Instead, there is a piece of electronic equipment that captures the incoming light rays and turns them into electrical signals. And if you have ever looked at a television screen closely, you will have noticed that the picture is made up of millions of tiny colored dots or squares called pixels. Have you ever noticed that? If you zoom in, you can see millions of,
Yeah, ma'am.
like this, something like this. Okay, so laptop, LCD computer screens also make up their images using pixels. Although they are often much too small to see, because they switch very quickly for our eyes. So light from the screen travels out to your eyes and your brain is fooled in to see a large moving picture. So in a digital camera, exactly the opposite happens. So light from the thing you are photographing zooms into the camera lens. This incoming picture hits the image sensor chip, which breaks it into millions of pixels and stores it as numbers. Okay, so this is where the entire digital process is happening. So your digital photograph is effectively an enormously long string of numbers describing the exact details of each pixel it contains. Okay, so this was about turning light into data. So that's how it is very easy and very fast to change and process your own photographs and share, because they are in the form of numbers. So now we define what a digital image is in mathematical term. I always wonder how everything can be expressed finally in terms of an equation. I remember a very nice sentence which somebody many years ago told me, that mathematics is a language of God, in which God has written down the entire universe. So whenever I learn a new concept and when I see that that concept is actually written down in terms of an equation, this sentence actually again and again it comes true, that actually this entire universe is a language, it's, mathematics is the language of God in which he has written the universe. So uh, I don't know if you are able to draw the analogy, what I wanted to tell you, but it happens to me. Anyhow, moving on. So digital image is a two-dimensional function, f of xy. It's a projection of three-dimensional scene into two-dimensional object. So the two-dimensional, all of us, we are living in the three-dimensional space. So it's basically projecting that three-dimensional moving object or thing into two dimensions. So digital image is a two-dimensional function that is a projection of a three-dimensional scene into a two-dimensional projection plane. So here you have x and y, which represent the location of the picture element or pixel and contains the intensity value. Okay, so when the values of x and y and intensity are discrete, then the image is said to be a digital image. So digitizing the coordinate values is called sampling, and digitizing the amplitude values is called the quantization. So thus, when x, y, and amplitude values are all finite, discrete quantities, we call the image as digital image. So when we do the projection in 2D image, it actually captures some intensity values which vary within some range of values. Okay, so when we see the image, we actually see those intensity values. So these are all your f of x comma y. So it is not only two-dimensional. Always it's not, because now the technology is moving so fast. Some of you may be having cameras with multiple lenses through which more than two-dimensional data can be captured. And you could see that you can do much more than this two-dimension. That is, you are able to get a modified version of images, or the foreground object can be highlighted, or the background can be blurred, portrait mode, etc. So all these things are possible because multiple lenses are there. So representation of the image is very, very important in this case. Okay. Why I say this? Because entire image processing application depends on the way you represent the image in terms of a matrix, and then to understand what you have to do. If you cannot read that representation, you will not be able to understand what to do, how to process it, because your eyes see the image in a different way and computer sees it in a very different way. So that is why the representation of image is very, very crucial, and it is very important to understand. So now the question arises, how does the computer see an image? So here is an illustration. The image is stored in terms of a matrix with some values. So these individual entries are the picture elements. So here you can see these individual entries, which are the picture elements or the pixels which store the value. Depending on these values, we could have a binary image or a grayscale image or a color image that we'll see what are these kind of images when we come to the MATLAB. So we will see those examples later on. In this example, each pixel is represented by a number from 0 to 255. That is the RGB color code, red, green, blue color code. You all know that these are the primary colors which when mixed will give you all the colors possible. So, if instead of black and white, the image was in full color for each pixel, we would have 3 values. Okay. So then the output array will be 12 by 16 by 3. So some computational problems can start rising from this. So normal sized image can use up an approximate of 2.4 MB of storage. From a deep learning perspective, this possesses a problem, as these models tend to need a vast number of examples for training. So I don't know, your seniors are not there with us, but usually whenever we take up a project on image processing or something like that, they are worried of data, the higher computational capabilities. All this is because it requires a bit of storage. And this is why training deep learning models for computer vision requires considerable computing power and evolves at a slower pace in the field. So the challenge is to make sense out of these numbers. As I said, your brain sees the image, your eyes see the image in a different way, and the same image is seen by the computer in a very different way. So we can see that it's an elephant here in the left hand side, but the computer sees the same elephant as a matrix of numbers. Okay, so here is that matrix. I will show it to you in a few minutes in MATLAB. So task in our hand here is to make sense as to, is there an elephant in this image? If I don't show you the image of the elephant, will you be able to make out from these numbers that this actually is an elephant? No, right? It will be very difficult unless and until you are trained in this way. Okay. So the task here is that only, that is there an animal in this image, or is there an, various problems arise, classification problem, recognition problem, etc., etc. So we need to make sense out of these numbers and answer the questions whether the image contains an animal or not. And that is why the task of understanding an image through a computer's vision is more challenging. Okay. So this is an analogy or a comparison, you could say, between human vision and computer vision. So here you have the input as an image. The sensing device is your eyes. The interpretation device is your brain, and the output is apple. Whatever the input was, you will get the same output. What happens with the computer vision? The input is again an image of an apple. The sensing device is camera. The interpretation device is computer. And the output is like this. The computer will say 85% is apple, 11% pear, 4% tomato. Okay, so this is how the result actually comes. So this is the accuracy. Okay. So with the more data or with the refined algorithm, you can increase the accuracy always. Okay, so this is image. Then we will see how to represent the image. So this is an image of a circle. Okay, so if you want to represent this matrix, one way, like see, you will have certain entries here. Since this is a black and white image, the entries will be 0 and 1. So one way of representing, looking at it, is that we concatenate the value row wise. Okay, row wise. Since the first row is not having any part of the image, we will take it as 0. So we have concatenated row wise the zeros, values row wise, and then convert it into hexadecimal representation. So we have converted the given image into one-dimensional array. How? By concatenating it row wise. So since we have a binary image, that is a black and white image, here the first row is completely filled with zeros. The second row is having 3 entries as 1, 1, 1, and so on. And further, we have represented this row array into a hexadecimal form. So what we have done, we have converted the binary image into one-dimensional array. And that is, we have kind of encoded an array of numbers. Okay, so now we are free to perform many types of operations on this one-dimensional array or image. So the advantage of this process is that this is reversible. Whatever processing we do on this array, and we want to get back, we do some operations on this array, we will get back the binary representation here. Okay, some other binary representation, because we have operated on this one dimension, and hence we get different set of zeros and ones here, and then hence we will get a different image here. Okay, so the advantage here is that the process is completely reversible. That's how you get the processed image. So these are all intensity values. 0 is for wide and 1 is for black. So another way of representation of this image may be in terms of how many zeros and ones are there in a row. So here you can see there are 47 zeros and 17 ones in total. Okay. So this is one representation, or there can be another representation where we can count row wise as to how many ones are there in each row. But there is a problem in this these representation. Can anybody tell me what is the problem?
Location we can't
The
define
location.
where one
Yes,
is.
We
ma'am.
can't specify
Position की
location.
information lose हो रही है.
Very good. We cannot identify where are the zeros and where are the ones. So with this representation, the same image will appear as a different image that we do not want. We want our input to be the same. Output is a processed image, we understand, but at least with the representation, we should get the same input image, right? So we need a unique representation so that we or computer can distinguish between two different images. Okay, so representation of an image is again critical depending on what is the underlying application that you are targeting, what you want to achieve, what is the question we want to answer. That's where representation is very important. So this slide is talking about the interplay between various associated fields of digital image processing. On left hand side, you can see an image of a human side face. On the right hand side, you can see the graphical representation of it with geometrical shapes. So this is one such representation of the object present in the image. And there are various arrows which show various fields. Okay. So first of all, we have the image processing arrow. So this is arrow is associated with a self loop. Okay. In an image processing algorithm, the input is an image, output is a processed image. So what sort of processing is done depends on the given task and hence the self loop. So for example, when we take a picture using our phone, we can edit it with different filters, like we can enhance its color, make it black and white and so on. So to all of them, the input is the image that you have given or you have opened, and the output is the same image with a modified feature. Okay, so this is what image processing is all about. Next, we have computer vision. Okay, computer vision, it is one level up. So in this, we take an image or a processed image or some feature of the image and try to represent it in such a way that some questions can be answered based on that. For example, in this example, given a human face image, a computer vision task is to extract the prominent features or the sense organs present in the scene and give it a representation in terms of triangles or geometric shape, which can further be analyzed with the pattern recognition techniques, which are associated with deep learning concepts. So those concepts require a representation to be very specific in some vector space. I think all the students here must be knowing what is a vector space. I need not elaborate on that. So conversion of an image, which is a two-dimensional matrix, if it is grayscale, convert it into feature space, which is basically a vector space. Then in that vector space, machine learning or deep learning algorithm are going to operate. So using some pattern recognition algorithm, we can draw some inferences associated with the underlying task image. Okay. Then there's another field of computer graphics. Okay. It is primarily for animations, gaming, various types of special effects in movies, and virtual reality. So there was this very nice example of an animated movie. I don't remember the movie name. Maybe it was Mimo or something. It is totally animated movie, but the animations are actually created with the help of quadratic formula. Okay, I was really amazed to see how that simple quadratic formula that we all come across in our 10th standard itself, that was actually used to make those computer graphics using the two roots, whether the roots will hit that particular light ray at what angle. That was the basic concept of drawing those animations. There are many good social blogs that are written or you can follow. One is the Format, with the name Format, that you can follow, which has actually a video on their social media account on Twitter, I think, which shows you using the simple mathematical concept of as simple as quadratic formula, how you can generate the computer graphic. Okay, as a first year student, you may be amazed. I don't know about the final years one. I was amazed because I am not from this computer science background, so it is really amazing to me. That's why I mentioned the name. So what computer graphics does is to take that interpretation and create the image. Okay, so I talked about this computer graphics. So it is then there is geometric processing. So there is again a self loop here, so which deals with finding the curvature of an object, smoothing out certain noises, or creating a three-dimensional view from a two-dimensional perspective. Nowadays it is very trendy because everything is online, so everybody wants the virtual reality. So in that, all these things are very, very important. In that, many other concepts of maths also come into picture: curvature and smoothing, derivatives, and a lot more. So all these tasks can be depending on the representation of image as a matrix. So your home takeaway messages image can be represented as a matrix. Okay, so I gave this slide not to burden you with many things, but just to give you an idea that this field is actually, if the foundation is good, then you can go further and do a good job if you're interested in. So these are some related concepts in the field of image processing. Okay, so the result of sampling and quantization, as I mentioned, is a matrix of real numbers. So we use two principal ways to represent digital images. Why two principal ways? Because, as I said, MATLAB, the indexing starts with 1, unlike the other programming languages, or unlike the normal convention of 0. Okay, so here you can see the coordinate conventions. So we say that assume that an image f of xy is sampled so that the resulting image has m rows and n columns. So we say that the image is of size m by n. The values of coordinates are discrete quantities. So for notational clarity and convenience, we use integer values for these discrete coordinates. In many image processing books, you will see that the image origin is defined to be xy as 0, 0. The next coordinate values along the first row of the image are xy 0, 1. So here, this is the one. The notation 0, 1 is used to signify the second sample along the first row. So it does not mean that these are actual values of physical coordinates when the image was sampled. So, but in MATLAB, you will have the convention as 1, 1. Okay. So I think this is clear. The order of coordinates is the same as the order is.
Ma'am, can you repeat this coordinate convention?
It is just how we name the entries in matrix, that way, like the 1, 1 entry, 1, 2 entry, like that. Okay, so that is the coordinate convention. So there is more to it. There's the coordinate. This is how the final representation is. So the coordinate system in the last slides and the preceding discussion lead to the following representation for a digitized image. So here you can see the digital. Each element of this array is called an image element or a picture element. So this is giving you the position, and then you have the intensity values f of 0, 0. So this is the normal convention, and this is the MATLAB convention, MATLAB matrix. Okay, because of the change of the origin. Okay. Notation f of p comma q denotes the element located in row p and column q. For example, if you have f of 6 comma 2 is the element in the 6th row and the 2nd column of the matrix f. Okay. So now we come to the types of images. The grayscale image. we have a grayscale image is a data matrix whose values represent shades of gray. So when the elements of a grayscale image are of class unit 8 or unit 16, they have integer values in the range of 0 to 255 or 0 to, if it is unit 16, then 0 to 65535 respectively. So if the image is of class double or single, the values of floating point numbers, values of double and single grayscale images normally are scaled in the range of 0 and 1. So although other ranges can be used, the term gray level is used often to refer to the intensity of the monochrome images. Okay. Then we will see how does a grayscale image look like. Usually there are 8 such gray levels. So you have 2 to the power 8. That is how you get the number 255. Okay, so color images, then you have the binary images, which each pixel can have either 0 or 1. So matrix that defines the image is a matrix with entries 0 or 1. So in this case, the image is set to white for 1 and black for 0. Then you have the color images in which they are formed by the combination of individual images. For example, in the RGB color system, a color image consists of 3 individual monochrome images referred to as red, green, and blue, primary or the component images. For this reason, many of the techniques developed for monochrome images, that is the grayscale, where you have single shades of gray, can be extended to color images, by processing the 3 component images individually. So now we have certain matrix operations. All of you must be familiar with the basic matrix operations and what are the conditions associated in order to carry out the matrix operations. So each of these matrix operations will give us a new image. So basic idea is we have 2 matrices A and B with some dimensions, that is same number of rows and columns. We can add them, subtract them, multiply them to get a new matrix, which is the processed image. So mathematical properties governing these matrix operations hold good here. So as an image processing expert, you will try to see how these properties can be utilized to enhance certain features of the given image to answer the questions in the underlying task. So I will switch into the MATLAB window now to show you certain basic operations. I hope I'm clear. Don't worry even if you do not understand certain things, because the purpose here is to give you an orientation as to what is image processing. You need not learn everything in this, so don't worry about it. So this is a live script that has been created here. So live script, again, you can go to the new, and then you can create this live script, and you will get the output here only. Live script का मतलब है कि output आपको वहीं के वहीं मिल जाएगा, unlike in the command window. So following script will read an image and store it in the variable I, which will be used later. So here I am reading an image of cameraman, which is already stored in the MATLAB in the .tif format using the command IAMRead, and I'm displaying this image using IAMShow of I. So when I run this, so you will get the image. Okay. So now if you want to see what this I is, okay, you can. This is a 256 by 256. Okay, so how computer sees it? See, this is the matrix. So 256 by 256 का ये matrix है. And what we see this image. What computer sees of the same image is this. Okay. So now if you want to convert this grayscale image to binary. Okay, binary means you will have the intensity values as 0 or 1. And we can use the command IAM2BW. Okay, IAM2BW, and then you can set some threshold value 0.5 I have set. So this will MATLAB will prompt you, See, I comma level it is showing. So you can give a threshold value as to 0.1 0.5 से जो ऊपर है उनके आप ये कर दो, मतलब you can set the value. So when you run it, when you display the image, you will get the binary image which looks like this. So this is the.
How can we set the threshold value? Can you explain it?
It depends on you. So if I do here 0.7, okay, it depends on the level that you want to use. So see here, if I set it as 0.7, then what happens to this image? The back here, see in the original image, some little grayish colors are now becoming black. Means जो 0.7 से 0.5 हमने जो पहले किया था, that was okay for.
So is it intensity value?
Yeah, it is intensity value. I hope you are able to get.
Ma'am, does one mean completely black or completely white?
One is completely black. So if we are going a little bit closer to black, it will, give the grayish also in terms of black. That's what happened. Okay. So if
Okay,
you want to
ma'am.
reduce it, say 0.3, we are closer to white. Let's see what happens. So it is cutting down on.
What is the range for this intensity value? 1 to 3 or 0 to 3?
No, this is going from 0 to 1.
Okay.
Be,
But
between.
table is okay. ठीक, right.
Okay, so what values does IB has now? So that is all these are 1, because these are all closer to 1, right? Because they are more of gray. There are shades of gray in this, so more of 1 values we are having here. See, that's what is there. Very less of 0 values, only for the background, which is this. We will have now. We will have to identify where are those zeros. Yeah, here you have certain zeros. Okay, so this is what making sense out of this image. Okay, so now we will read another image of chest x-ray. So here you can see this is already a binary image. The values, this is a 493 by 600 unit 8 matrix, and the values mostly are 0 because the background and these things are mostly there are white shades of white here and very less of black here. And then if you use the size function, size of f, it will return you the dimensions of the array. And then you have I have taken another image of a rose. If we do whose G, it will return the name, size, bytes, class associated with G. Okay. So
Excuse me, ma'am. I have
yes.
one doubt. Ma'am, actually, the leftmost corner of the image is represented by the 0 at the position of 1, 1.
Yes. Leftmost. Yeah,
The
here.
leftmost one will be represented by 0, 0, 1, 1.
Yeah, you
Ma'am,
can
but
divide this image into how much is this? 493 by 600. 493 rows and 600 columns. Okay, like this. And very, very small doubt, like this will be your 1 entry.
ma'am, but in the above that graph, in the matrix, it was representing 0, 0 for that black part. That's why I got confused. Yes, ma'am.
Yeah, so
Just X-ray.
yeah.
मैम
Yes.
मैम आपने इनिशियल में आपने बताया था कि 0 से व्हाइट रिप्रेजेंट करते हैं और 1 से ब्लैक, लेकिन जब आप मैम आगे पढ़ा रही थी तो उसमें आपने 1 से ब्लैक दिखाया और 0 से 1 से व्हाइट दिखाया, 0 से ब्लैक।
ओके, तो वो उल्टा हो गया क्या?
मैम जैसे जहाँ पे आप हेक्सागन मतलब उसमें बाइनरी का रिप्रेजेंटेशन कर रही थी, वहाँ पे जो ब्लैक था वो
हाँ,
आप
वहाँ
वन
पे
से
0
डिफरेंस कर रहे
वाइट के लिए था।
हैं और 0 वाइट के लिए था, और यहाँ पे उल्टा हो रहा है।
नहीं, यहाँ पे ये वन वाइट के लिए, इसके लिए हो गया है, बिकॉज वी हैव कन्वर्टेड इट, इट इज अ कन्वर्टेड इमेज, और ये ऑलरेडी हमारी बाइनरी इमेज है, सो मे बी उससे डिफरेंस आ सकता है। सो दैट इज 0 इज रिप्रेजेंटिंग हियर the black here, but let's see further what is represented. यहाँ पे ये जो रोज वाली इमेज है, let's see what are the dimensions of it. G is it's not a binary image. You have to convert it to a binary image, then you will get. So this is a grayscale image. Let's see. I have converted the spheres in binary. Next, let's see that further. You can all see in your system also. Okay. Okay. So there is
Okay,
this
ma'am.
pairs. You can all find out, sort it out, which is what in your systems as well. And then we have peers image here. So here you can see there are 3 components. This is 256 by 256 unit matrix, and you have you can display each component. That is the red component 1 by 1 by 3 unit 8 matrix. So you have these 3 components, and you can get the how many entries are there in each of the components. So first is having 138, second is having 158, and third is having 130 entries. So row vectors. So each matrix can be seen individually like this. So if you want to see the red channel, you just have to give I am show I see this image colon comma 1. That is the red channel. RGB 1 is for red, 2 is for blue, and 3 is for, sorry, 2 is for green and 3 is for blue. So similarly, you can see the green channel with the 2 and a blue channel with 3. So blue channel is little bit dark here. Okay. And red and green channel are almost the same. Okay. So in the red channel, you can only see from the original image, you can only see the, very shades of the skin. Wherever there is some yellow or reddish skin, that is highlighted. Okay. In the red channel, in the green channel, the skin is not highlighted. The main apples pears are highlighted, and in the blue channel, it is darkened. Okay. So
Ma'am, but
yes.
when we are directing it to either blue channel or red channel or green channel, why it just looks like grayscale? Like we have put it in the grayscale, but the contraction is different. I think so.
Yes, ma'am.
We are only highlighting the, yeah, it will be like that, no? Because we are only highlighting one color, so it will be in terms of monochrome image, unlike the RGB. So that is why it is looking like that. Okay, only that part of RGB is highlighted here. So here it is blue is highlighted. Okay. So each image layer can be processed
जैसे
individually. And then we can binarize each layer separately, or you can binarize the original image also by again giving the threshold. So if here the red layer, the first layer, that is the red layer, has been binarized with a threshold of 0.5 level, and you can see. So where was a red channel? Here was a red channel. So now let us see what is ICB. How does it? So here one is the first entry here. So that little bit of white is here. So I think 1 is for white. If I am, again you have 1, Again, you have 1 and then you have 0, 0, 0 and then you have 1 again. So I think 1 is for white. The one
Yes,
that
ma'am.
mentioned.
1 is for white.
Yeah. So binarizing the blue layer. So here in the blue layer, you can see mostly it is very close to black. Okay, everything. So when we see its matrix, yeah. So we have this is the when we see the matrix here, it is 1, 1, and then you have zeros and very less of ones. Okay. Okay. So then we will perform some basic operations on matrices. Again, we read the pairs image and we add the green and the blue channel using : : 2 plus : 3. Okay. So what is happening? This is the resultant image. But can you tell me there is some problem here? So you have seen what is your green channel is having these entries, okay, and your blue channel is having these entries. So when we element wise, when we add them, what is happening? Are we getting these values which have appeared on as A? Is there any problem in this? Can you let me know?
Ma'am, I didn't get your point.
See, what I'm asking here is यहाँ पे जो है the entries of the green channel are क्या है entries के 122, 92, 95, 99 इस तरह से हैं और इसी तरह से
मैम,
blue
हो सकता है कि इन दोनों की इंटेंसिटी प्लस होने के बाद में 256 से ऊपर हो रही हो, दैट्स व्हाई
हाँ
255 लिखा हुआ आ रहा है। इंटेंसिटी
yes
मैक्सिमम जो 255 आ रही है।
right
यस
right
मैम, और मैम रिजोल्यूशन के अकॉर्डिंग भी हो नहीं, रिजोल्यूशन तो डिफरेंट है।
इंटेंसिटी दोनों की प्लस होकर के जो 255 से ज्यादा आ रही है।
yes but it is being taken care internally by MATLAB but जब आप किसी और लैंग्वेज में या किसी में कर रहे हो तो you have to take care of this fact while doing the addition. You have to make sure that you set a proper threshold and then perform, whereas in MATLAB this does not arise because it automatically 255 के अंदर में उसने कर लिया है. Okay, so here you can see all the values is 255 and when we combine the green and the blue channel, you get the resultant processed image as this. Okay, so you need to think of the range of intensity values. Okay, range may go beyond 255 while adding the elements. Okay, so then we have the subtraction. Subtraction में क्या है? Difference will be highlighted. The same thing we will do for the green and blue channel here. We will subtract them and we will show. So here you can see the difference between the green and blue channel is highlighted. Green और blue channel की कैसी image थी? हमने यहाँ देखी थी. This was the green and this was a blue. So आपको difference देख रहे हैं आप? There is only this shiny skin का difference है. So that difference is highlighted in subtraction. ये देखिए. ठीक है? So similarly, if we try to subtract the green and the red channel, green and red channel. So here not many things have highlighted because in this image, what happens? The green and the red channel are almost similar. Okay. That is why not much of difference has been highlighted.
Ma'am, but it is completely black. We can't figure out anything.
Yeah, because both the images are similar, na? That's why. There is not much of a difference to highlight. आप देखें इसमें
Can you show the matrix of This one red minus green. Sorry, green minus red. Show me the
Yes.
matrix. Its value should be 0, 0, 0. No, all level 0.
No,
Oh,
no.
no, but
There's
20.
some
Okay, okay.
difference. And this is not a binary image. So that is
Mhm.
why there will be intensity values in this. If you
Okay.
convert it to binary image, you may get, I think, in terms of ones. I think ones. You should get it in terms of ones. You can do that with
Ma'am,
computers.
I got
Yes.
one more doubt. Ma'am, when we are removing one type of specific color or one type of channel we are directing in, ma'am, why we are getting a grayish effect on the image instead of some other color like where combination of green red? If we remove blue, then we should be seeing a color which is combination of green blue. But sorry, but ma'am, why we are moving towards the grayscale?
No, see, the subtraction means the difference. It will give the difference of so it will remove that those colors. So it will eventually move to the grayscale, right? Shades of gray will be highlighted.
Pardon, please, ma'am.
I said subtraction is highlighting the difference. So if that some color has been removed, then it will move to the grayscale. That means shades of a monochrome scale.
Okay, ma'am.
So that is why you are getting a
Excuse me,
grayscale.
ma'am.
Yes.
Ma'am, what do the two columns in the beginning signify?
These are as I said, the color image is three-dimensional. Okay. And the third dimension is RGB. So these two are for the intensity values, and the last one is for the color RGB dimension. Okay, so that means when we defined what is a grayscale and what is a color image, the main difference was that color image is also grayscale image, but with an extra dimension attached to it, which is the color
Excuse
dimension.
me, ma'am. Anupam here.
Yes, sir.
Yes, I sent the feedback form. It is request for all the participants. Please fill it. That will help us. Thank you, ma'am.
Okay. Okay, so here the first two columns, they are actually representing the intensity values. So when we studied about the grayscale and the colors image, we saw that the color image is having one extra dimension to it, which is the third dimension, and which is giving us the RGB, the color. Okay, the other two dimensions are for the gray scale, that is the intensity values. Okay, that is what the colons means. Okay, now we will see another image of rice. So objective here is to extract the rice grains from the above image, and if possible count. I have not counted here. You can do it as a homework. So what we need to do is remove all the rice grains first using this command. That means we have to extract the background image. Okay, and we have to separate the background and the rice image. So and then we separate the background as I am open, IC, comma SE. So this is how we have subtracted the background. Okay, background of this IC image. So then subtract this background approximation image background from the original image, and
मैम
yes,
एक बार ही वापस बता दोगे क्या बैकग्राउंड वाला?
ये वाली इमेज है आपके पास में.
यस मैम.
ठीक है, तो इसमें से हमारा ऑब्जेक्टिव है कि ये जो राइस है यहाँ पे इनको सेपरेट आउट करना. मतलब क्यों करना? ताकि हम इसको काउंट कर सकें. अब काउंट मैंने इस एग्जांपल में नहीं किया है, लेकिन यहाँ पे मैं सिर्फ सब्ट्रैक्शन का एप्लीकेशन बता रही हूँ. तो उसको करने के लिए आपको जो बैकग्राउंड का है, बैकग्राउंड को आपको सेपरेट करना होगा. और फिर इस इमेज से जब आप उसको माइनस करोगे तब आपके पास में नंबर ऑफ राइस ग्रेन्स आ जाएंगे. ओके. So we have extracted the background image using the Strel this 15 and then
मैम एक बार इसका कोड वापस बता दो मैम, बैकग्राउंड एक्सट्रैक्ट करने वाला.
यही बता रहे हैं बेटा. So remove all the rice grains. First you have to get this Strel. Strel is a disk shaped structuring element with properties. तो ये आप help में जाएं और इसको देखें कि ये क्या चीज है. ठीक है. Now that you know what is help. Okay. So and then you have the background with IM open IC, SE. तो इसकी मदद से हमने बैकग्राउंड इमेज को सेपरेट कर लिया है. एंड देन वी हैव दिस बैकग्राउंड, मतलब बैकग्राउंड उसका अलग आ गया है. नाउ वी कैन सेपरेट द बैकग्राउंड फ्रॉम द ओरिजिनल इमेज. एंड व्हेन वी सी दैट, व्हेन वी मेक दैट सबट्रैक्शन, वी सी दैट the resultant image is little bit blur and it needs to be adjusted so that हमें राइस ग्रेन अच्छी तरह से दिखे. तो उसके लिए I am adjust फंक्शन लिया है और उससे हमें थोड़ी सी enhanced, मतलब थोड़ी ब्राइटन अप होकर के इमेज दिख रही है. Okay, so now the rice grains are working. I mean they are visible properly, and when we binarize this, they are more prompt to. Yes,
ma'am, when you just adjusted that image and when you opened it out, we can see some white spots in the back of the background. So ma'am, is it the inefficiency of the program or the hardware?
Let me see which are the white spots.
Yes, ma'am.
Yeah, it is the kind of noise because we are actually intensifying it. So it is the noise. So again, you need some more functions or some more mask to remove that. Here the rice grains are bigger, so we need not worry about those background dots, white dots. But if the rice grains or if there was anything else which was to be confused with those dots, then this method would not have worked. So that is what image processing or reading an image is all about.
Ma'am, so to reduce the chances of such noises in the first go only, what we have to do? We have to use a higher resolution image or a lower resolution image?
There are different algorithms for noise reduction also. You need to develop filters using the differential equations. And once you have created those filters using your differential equations, you can apply them on this image so that the noise is reduced. That is altogether a different algorithm. Okay.
Okay, ma'am. Thank you.
Okay. So now we come to the multiplication. Multiplication here I will demonstrate to you by creating a simple mask for this input image. This is a image of coin. So I'm reading this image and I want to create a mask using this maxgl. You can all go to your help and see what this max I have defined it as maximum of maximum of this image. What does this max mean? Can anyone tell me?
Finding a maximum value of among all the pixel values.
Okay. Anyone else would like to add on, or is this the one? Yes, you are right.
Maximum intensity.
Yes, so maximum intensity, that is to be precise. So we have stored the maximum intensity in this variable and then we define the mask as all the values, intensities values which are greater than this value divided by 2. We have again scaled the max GL to half, and then we say the mask that we have is actually those intensity values which is greater than the scaled maximum value. Okay, so then the mask image is displayed. So this is the mask image. I think this is clear. So this is the mask for the original image. Now we will apply this mask on the original image. So how we will apply? Unit 8 of mask dot star I. So again here dot star is used for carrying out element wise thing. Are you doing it on your computers?
So can you explain the unit 8 mask function? Hello? Hello?
Yes, sir.
Unit 8 mask function.
This is unit 8 is actually I mentioned there are two representations for matrix in MATLAB, that is unit 8 and unit 16. So in unit 8 you have the values from varying from 0 to 25. Okay, so that is what the convention we are using here. Data type. Okay, this is the data type for unit 8 is the data type wherein the range is 0 to 255. So the mask that we have created, we are just using it in unit 8. So you can see the matrix of the mask here. So here it is mentioned, it is logical array. Okay, usually what it mentions, so here when we see this I, when we see the matrix, unit 8 matrix, it mentions. But when we create this mask, it is not mentioning that way. So that is why this unit 8 is used. So here when we see, it is going to give us a logical array. Why? Because this has been created using a logical operation here. Okay, so when we are applying this mask, then we have to mention that you should get the unit 8 representation of this mask. Am I clear?
Yes.
Okay. So unit 8 here. Okay. So now we have applied the mask using dot star. That means we have एक तरह से इस इमेज को ओरिजिनल इमेज के ऊपर रख दिया गया है, तो उससे क्या हुआ, ये इमेज आई. वी कुड एक्सट्रैक्ट द कॉइन्स. This is a very vague example for what you say. I will show you one more edge detection. I think that is also very similar. So we have created this mask to actually see the edges, edge detection. So you can see the edges here. Wherever the intensity is changing drastically, this image is actually telling you that. So when we apply this mask on the original image, it enhances the edges. So we can go to edge detection here. So we have various other filters in MATLAB. So here again, just to detect an image using both Canny edge detector and Sobel edge detector. So these edge detectors are basically very classical edge detectors, which are again matrix only. They are the mask, but with first order ordinary differential equation and second order respectively. I don't know, I'm not sure between the orders of differential equation, but they are formed with the differential equation, the matrix that has been that is there to for the Canny and Sobel is using the differential equation. Okay, so here we read the coin image again. We show the coin image and then we say that IN is equal to 255 minus I. Okay, we have subtracted from each entry of I 255 and then we see the image like this. This is the negative of the image. Okay, this is a negative. This is how we have created the negative. Now we apply Sobel Uncanny. So MATLAB has inbuilt a function of for these two. You just have to type Sobel and you just have to type Canny and you will get the edge detectors like this. So this is the Sobel filter. When you apply the Sobel filter to the original image, you will get this. And when you apply the Canny filter, so see, you can see the Canny filter is more accurate because it is giving you the edges present in between the coins also. So the idea here is differentiation. That's what I told you. The Sobel and Canny, they work on the idea of gradient. Find out the gradient wherever the intensity values are changing drastically. It will take that. That is the d by dx, rate of change. So then we have this RGB to grayscale. If you do that, I am showed differentiation, the gradient of I gray. So we can, I think I should just run this first. So here in this image, so this is the original image of peppers. And when you see this image, we converted this to the grayscale and then what are we doing? We are differentiating this image. So what is happening? See, can you see these edges? Can you see the edges here?
Yes,
so it is showing you the change. Okay.
मैम इमेज को कैसे डिफरेंशिएट कर सकते हैं मैम?
अरे भाई इतनी देर से मैं यही तो बोल रही हूँ. इमेज इज अ मैट्रिक्स ऑफ नंबर्स, इंटेंसिटी, एफ ऑफ एक्स वाई, एफ ऑफ एक्स वाई.
मैम उसमें तो सारे कांस्टेंट्स है ना.
देयर आर सर्टेन न्यूमेरिकल मेथड्स. हमेशा जो आपने अभी तक पढ़ा है 12th स्टैंडर्ड में डी बाई डी एक्स ऑफ एक्स, इस तरह से ना हो करके यू हैव सर्टेन न्यूमेरिकल डिफरेंशिएशन. न्यूमेरिकल डिफरेंशिएशन होता है जो अभी पढ़ोगे, विच इज इन द नेक्स्ट यूनिट फॉर यू इन द फर्स्ट ईयर. न्यूमेरिकल डिफरेंशिएशन इधर अप्लाई होता है. मतलब वो नंबर्स का, मतलब जैसे कि जब हम डिफरेंशिएशन की डेफिनेशन पढ़ते हैं तो वो क्या होता है कि x प्लस डेल्टा x है ना, ऐसा होता है ना, डिवाइडेड बाय h, ऐसा कुछ होता है ना. तो वो ही नंबर्स में डिफरेंस, दैट इज न्यूमेरिकल. यू विल सी इट. तो वो ही होता है यहाँ पे. So now we can segment the differentiated image to get the sharp edges. तो यहाँ पे देखा आपने sharp edges दिखी इस images में. ऐसे तो दिख नहीं रही, but when you expand it, I showed you here the sharp edges here you can see. So and then there are various things that you can do. If you take the threshold value as 7 and when if you want to say that I edge is greater than equal to threshold value equal to 25, मतलब उनकी values आप 255 कर दो और जिनकी जो intensity value less than 7 है उनकी 0 कर दो. तो this is what you get. So you can play around with your image like this as and when you understand certain things. So then you have the Sobel filter and Canny filter. You can see the difference here. So then you have the reducing noise. Somebody asked me about the noise. So ये है about the reducing noise. ये है हमारी basic image and add some Gaussian noise. तो Gaussian is basically probability density function में जब bell shaped curve बनता है, you have the values ranging from 0 to 1. तो उसमें आपने गॉसियन नॉइस को इसमें ऐड किया है. and then you use the Sobel gradient. These are all the high level. I'm not sure if the first year students will understand, but you will definitely when you go higher. So this is the matrix for the filter. Actually the filter जो कि इस तरह से बनता है, इस तरह से ये जो -1 -2 -1 है हर एक डायरेक्शन के लिए, ये y डायरेक्शन में बना है, इसी तरह से x डायरेक्शन के लिए है। तो आपके पास में 8 यूजुअली जो फिल्टर्स होते हैं वो 8 डायरेक्शंस में भी हैं, तो दीज आर फॉर x and y, horizontal and vertical.
Ma'am, can you
Then
share
have,
all these examples after the class?
yes, I can share it in a zip file.
Yes.
I will share it. And then you have this central difference. There are certain numerical techniques of difference. There's forward difference, there is backward difference, central difference. तो इसी को अप्लाई करके ये सब आप पढ़ोगे अभी फर्स्ट ईयर में, तो वापस से फिर हम ये चीजें करेंगे। तो ये जो है इसी तरह से बनते हैं। Okay, so this was all about. I don't want to go in. तो सारे फर्स्ट ईयर स्टूडेंट सोचेंगे पता ही नहीं मैम तो क्या ही करा रही है। So do you have any doubts and I can take them up? Else I would like the volunteers to float the attendance, please.
Yes, ma'am, it is there in the chat box.
Okay.
Yes, ma'am. Stop the recording.
कुछ समझ में ही नहीं आ रहा था।
Yeah, you can stop the recording.
Ma'am.
When will you share all this recording and